All right, the equation of lines then. So the linear function. We know all lines can be written in the form y equals mx plus b. Okay? And of course, m is the slope or the gradient. B turns out to be the y-intercept. Of course, another way we write lines is in what we call general form, where we make it always equal to 0. So that's what we call general form. Now, some people say that A should be positive. Doesn't really matter. It just looks neater, I suppose. Often people say A, B, and C have to be integers. Well, that's not true. Because what happens if the coefficient is the square root of 2? You can't make it an integer, can you? So that's why I've added in there or certs, or something like that. Okay, so we're going to find the equation of line perpendicular to 5x minus 2. We also know it goes through 0, 6, and we're going to put it in general form. So we know it's perpendicular, so the slope will be the negative inverse. The slope we want, therefore, is minus 1/5. Fortunately, the point, how nice was that? The point I was given happened to be the y-intercept. Gosh, that was lucky. So we can go y equals mx plus b minus 5th x plus 6, but they did say general form. So I'm going to multiply everything by 5, move it to one side, and there's our line. Now, there are two very special lines, of course, and they are lines parallel to the x-axis, which always have the form y is equal to a constant. There it is. So I've just said, well, if that happened to be the point, all you need to know is one point. Because y is a constant, as soon as you know a point, you know the equation of the line, because y is constant. So therefore, that line would be y equals 2. And of course, we could have ones parallel to the y-axis. Similar thing happens. X is equal to a constant. If it was going through the same point, then that one would be x equals 3, because it's x is the constant value. Ooh. There we go. That was good. Very quick.